Lesson 3, function notation. So function notation refers to a notation that is used to show the independent variable in a function. So let's first start by talking about what a function is. So I'm going to draw myself a little box here. This box here is going to represent function f. And now we're going to say that I have an element x. And that element x is going to be put into my function, and it's going to come out the other side as something that we can call f of x. Okay, so the element goes in and it comes out as a different element. So that's where our two sets come in. And it's said that it is a function of f at value of x. So we have x, we put it in there, something will happen to it, it comes out as f of x. So let's say that x was actually 2. So I'm putting 2 into here, and we're going to say that f stands for, we're going to say, what are we going to do to it? We're going to multiply it by 5. So if I put 2 in and I'm going to multiply it by 5, it's going to come out the other side as 10. Same thing happens as if I was to put in 3. 3 is going to go into this function, and 3 is going to come out of this function as 15. Now, if we took a look at x again, and we say we put x into this function, now that we've multiplied it by 5, x is now going to come out of this function, so it's going in, and it's now going to come out as 5x. Okay, so what this says is that f of x is the function of x, and it's going to be written as the following. So f of x is the function of x, and when we write it, we're going to say f of x, and it's going to equal whatever you're doing to x within that box. So in this case, we were multiplying it by 5, so it's going to equal 5x. So f of x is what comes out of the box, and x is what goes in, and everything in between is what are you doing to x. So you're going to tell me what you're doing to x to get what your answer is on this side. So this here is what we would call a function evaluated at x. Okay, so this is how we write function notation. Example 4, it says, but it's example 1 for the case of this lesson, wants us to write this formula in function notation. So first thing we need to do is we need to determine what is our dependent and what is our independent variable. So a dependent variable depends on something else. So when we look at this, we say we have c is equal to 300 plus 30n. So c is dependent, the value of c is dependent upon whatever value of n we put in, because we can change the value of c by changing the value of n. I can't change the value of n. So we're going to say dependent is c, and our independent variable in this case is n. Okay? So when we want to write this in function notation, we have to write it in what we call a one variable equation, which is function notation. So function notation is one variable in terms of another variable, and this one here is what we would call two variable equations. So we're going to take a two variable equation, we're going to turn it into a one variable equation or a function notation. So c is dependent on n, so we're going to go c of n, because that's what it depends on, is equal to, and we're not going to change anything else. So when we write something in function notation, it's always your dependent variable in terms of, so dependent in terms of your independent variable. So c in terms of n is equal to 300 plus 30 times n. So it just tells you that c depends on whatever your value of n is. So let's take a look, and we're going to work with this a little bit. So we're going to evaluate values in function notation by substituting your value into the function and solving for what it is you don't know. So if I want c of 20, that means that I am now going to take my function, which was c of n is equal to 300 plus 30n. And I'm now being told that I want c of 20. So if I want c of 20, if you've noticed from step 1 to step 2 here, my n was replaced by a 20, which means anywhere I see an n, I'm just going to put 20 in. So we now have 300 plus 30 times 20. And now what I can do is I can add, subtract, multiply, divide, do what I need to do to make this work. So c of 20 is now equal to 300 plus 600, which means it's equal to 900. So C20 is equal to 900. So the value of C when your value of n is 20 is 900. Now we can look at this the opposite direction as well, and we have C of n is equal to 750, which means that your entire function equals 750. So I can write C of n was still 300 plus 30n. But now I'm being told Cn is 750, so I'm going to replace the entire value of Cn with 750. I'm going to leave the other side the same. And now what I'm going to do is I'm going to solve for n. So I want to isolate that variable. So what we're going to have to do is we're going to have to subtract 300 from both sides because you do the opposite of what you're currently doing. And that's going to leave me with 450 is equal to 30n. Now to get n by itself, I'm going to have to divide by 30 because I'm multiplying. So if I divide, it'll get rid of it. And when I take 450 and I divide it by 30, I'm going to get 15 is equal to n. So our function is equal to 750 when the value of n is 15. Example number 6. Very similar. It wants it written in function notation. So it says the equation v equals negative 0.08 d plus 50 represents the volume in liters of gas remaining in a vehicle's tank after traveling a distance, which is d, of kilometers. So write in function notation. So right now, the amount of gas you have left, v, is dependent upon your value or your amount of travel you've done. So the volume is dependent upon the number of kilometers you've driven, which means I can now write this as V of D is equal to negative 0.08 D plus 50. Because I know that my V is my dependent and my D value is my independent. One depends upon the other. Now it wants us to evaluate V of 20. So it wants me to take VD 0.08D plus 50, and I'm going to replace all the D's in this equation with a 20. So if I took negative 0.08, multiplied it by 20, I get negative 1.6 plus 50 is going to give me 48.4 liters. So after I have traveled a distance of 20 kilometers, I will have 48.4 liters of gas left in the tank. Now we're going to use the same equation, so we still have VD is equal to negative 0.08D plus 50. And it wants to know at what point, how many kilometers have I driven to have 49.6 kilometers left? Because if my volume is equal to 49.6, that means I have 49.6 liters. And I want to know how far have I driven if that's what I have left. So we're going to replace VD with 49.6, and we're going to solve for what D is equal to. So in this case here, I'm going to subtract 50 from both sides because I'm adding 50 currently. I want to get rid of that 50. We're going to subtract it. So if I subtract 50 from both sides, I'm left with a negative 0.4 0.4 is equal to negative 0.08 times d. And now I'm going to divide by negative, I'll show you it's a different color, negative 0.08 to get rid of it. If I take negative 0.4 divided by negative 0.08, I'm going to wind up with 5 kilometers is equal to d. So I will have 49.6 liters after 5 kilometers. That's what that's telling me.